Find the relative extrema of the function f of x is equal to x plus 1 over x. Okay, in order to find the relative extrema, extrema is minima and maxima, we have to find the derivative of f and find the critical point and the value of x where f prime is undefined, and then do the first derivative test, right? So let's find f prime first. That is equal to 1. Derivative of 1 over x, that's x to the negative 1. So if we apply power rule, that's minus 1 times x to the negative 2. So that's 1 minus 1 over x squared. If we combine these two terms, that's x squared minus 1. Numerator can be factored, x minus 1, x plus 1 over x squared. That's our f prime of x. Now, f prime of x is equal to 0 when x is equal to plus or minus 1. And f prime is undefined when x is equal to 0. Now, let's do the first derivative test. This is number line x. We have negative 1, 1, and 0. So we have to test each of these intervals. Let me write f prime here. I'm going to pick negative 2 as a test point. If we substitute negative 2 for x, denominator is always positive, right? So we don't have to worry about this. Negative 2 minus 1, that's negative 3. Negative 2 plus 1, that's negative 1. So negative times negative, that's positive. So positive here. Let me pick negative 1/2 for this interval. If x is negative 1/2, this is negative. If x is negative 1/2 here, this is positive. So negative times positive, that is negative. Pick 1/2 here. If x is 1/2, 1/2 minus 1, that's negative. 1/2 plus 1, that's positive. So negative times positive, that's negative. And lastly, if we choose 2 as a test point, 2 minus 1, positive, 2 plus 1, positive. So positive times positive, that's positive. So we know that f is increasing here, decreasing here. But when x is 0, the function f of x has vertical asymptote, right? Because if x is 0, denominator will be equal to 0. That means f of x has a vertical asymptote at x equals 0. That means when x is 0, neither minimum nor maximum exist. From 0 to 1, function is decreasing because the f prime is negative. If x is greater than 1, function increases because f prime is positive. Therefore, we can conclude that we have relative maximum when x is equal to negative 1 and relative minimum when x is 1. So relative maximum is f of negative 1, that is equal to negative 1 plus 1 over negative 1, that's a negative 2. And the relative minimum is f of 1, so that's 1 plus 1 over 1, which is equal to 2.